He is deeply committed to collaboration, knowledge sharing, and academic excellence. I warmly welcome him today, sir. Please share your valuable knowledge with us. Thank you.
Thank you, madam. Thank you very much for this nice introduction, and good morning to one and all present here. My sincere gratitude to you as a session host, the session chair, Professor Shiv Prasad, and Dr. Santanu Modak, the dean, who is a very good friend of mine, the respected principals and all other members of the college, and definitely most importantly the attendees, the faculties who are attending the session. So it's my pleasure to be part of this FDP as a resource person, and I'll try to learn few things also during the session through the questions if I get. So please let me know that whether my screen is visible or not. Can you see my screen, madam? Is it visible?
No, sir. Yes, sir. It's visible.
I think the presentation is also, you can see, right?
Yeah, yes, sir.
Is it okay?
Yes, sir. It's okay.
So as I'm seeing my entire screen, so anytime if my voice or screen is not visible, kindly let me know.
Sure,
I think that will be better for me to.
Yes, sir. Sure.
Okay. So again, it's my pleasure and honor to be invited as a resource person. So the FDP that is being organized by the Department of CSC IT, CSC AI, ML and CSC Data Science of Bengal College of Engineering and Technology, Durgapur, on the field Emerging Computational Paradigm and Research Frontiers. I was going through the different topics, and that has been identified with deep thought. I've seen all the sessions. There are many sessions, or even almost all the sessions are enough to give the food for thought for the faculty members, the young researchers, and I'm sure that will help all the faculty members to get the required input for their respective research domain. As far as my topic is concerned, I will be talking on the application of machine learning and recommendation systems for sustainable healthcare. So if we go through the topic, the title, exactly here we are getting three terms. One is machine learning, second one is recommendation system, and third one is sustainable healthcare. So what I'll try to do, I'll try to go through these topics at first, the basic concept. What do we mean by, there may be who are new into the machine learning or recommendation system or even sustainable healthcare. So who are aware about those topics? I just
I just pause you. Sorry for that. Sajal sir, can you check that YouTube live is properly work or not? It's working, but whatever I see that it's only. Sajal sir, can you check that YouTube live? But it's showing that only a black screen. Yeah, you just check in YouTube. Dhrubasish sir, sorry sir.
No, it's absolutely okay, sir. It's like I don't have any issue with that. So please confirm.
Okay.
From my end?
No, sir.
Yeah. Okay.
Yeah, it's perfectly working now.
Sir, is it okay, Santanu sir? Can I go ahead?
Yeah, sir. You please continue.
Okay. Thank you, sir, for the feedback. So we will be talking here three areas that we will focus. One is that basically machine learning, recommendation system, and sustainable healthcare. So that is what I have requested, who are a bit aware or who are expert in this field, maybe in machine learning or recommendation system, to bear with me for a few minutes so that we can give the chances to the newcomers in this field about the basic concepts. Okay. So this is the agenda, what I'll try to cover today. I'll try to discuss as I've mentioned, that basic concepts of AI, machine learning and recommendation system, because if we'd like to talk about machine learning, definitely that comes from AI. So we must give some introduction on AI. We'll try to understand what do we mean by the sustainable healthcare, because sustainability is a major issue. Like it's an issue for each and every aspects of our life, industry, society, health, education. So sustainable healthcare, what do you understand, or what is the basic concept of sustainability? Why we are talking about sustainability so much, that we'll try to understand a bit. We'll try to see how machine learning can be used in healthcare. I'll use some of the use cases. We'll see what is the recommendation system and what is the role recommendation system can play in healthcare. Recommendation system is basically going to lead the healthcare and other areas for next 2 decades at least. So we'll see that how recommendation system can enhance the healthcare services. We'll discuss some of the case studies and some of the practical applications. Definitely, whenever we are talking about AI, 2 other terms which are very much common nowadays, that whether we are using AI ethically or not. There are new branches has been started, that is a ethical AI or responsible AI, or whatever answer we are getting from the AI, whether any biasness is there or not. So definitely we must try to explain that AI results. So explainable AI, those are the different areas those are coming up. So we'll try to throw some light, not in details, but throw some light that what is the ethical consideration, responsible AI. We'll try to see what are the challenges, because each and every technology comes with some advantages and definitely comes with some challenges also. So we'll try to throw some light on what are the challenges, particularly the privacy and a few other aspects. We'll try to see what may be the future direction in like coming days, how healthcare can be reshaped with the help of machine learning and recommendation system as or overall as AI. And at last, I'll try to throw some light. We are having some research, although not very large scale, but few research in this field we have done on mental health using machine learning or AI, or to some extent the recommendation system. So I'll try to show some of the research findings that I, along with my group, we have worked with. So three terms which are becoming the buzzword nowadays, that is artificial intelligence, machine learning, and deep learning. So what do we mean by artificial intelligence? Although we broadly know, but I have tried to identify 3 definitions. I've taken definition from Stanford University, who are pioneer in this field. I've taken definition from Wikipedia. I've taken definition from Coursera, and almost they're telling the same thing. The essence are same, but they're telling from different aspects. Like if we go through the Wikipedia definition, if you search what is AI on Wikipedia, as per Wikipedia, AI is the intelligent machine or software. So definitely AI system you can build using machine and software, which are basically opposed to the intelligence of human or animals. So you are studying AI, actually it's a field, subcategory or category of computer science, which are basically helping us to develop the intelligent machine. Intelligent machine such that the machine will act like a human, which helps us to take decision or to act or to perform some actions like a human. This is what Wikipedia says. Now, if you are going for the Stanford, one of the very renowned professors who have studied AI, in the, like all of us as a teacher or researcher who have studied AI during our undergraduate, postgraduate, or even during PhD time. So we know that John McCarthy is basically the pioneer in this field, in that sense, who has served Stanford University. So he's a Stanford professor. So he has given a very smart and small definition for AI. AI means, as per Professor John McCarthy's definition, AI is the science and engineering that making intelligent machines. So the definition is saying the same thing that earlier Wikipedia is saying, but then the definition is very concise and very smart. Now, Coursera, one of the leading MOOC platform, massive open online courses platform. If we go to Coursera, as per Coursera, the AI is basically the theory and development of computer systems, which is basically parse capable, which can do some task. Normally, those tasks where the human intelligence are required. So the same thing, if you compare it with the previous or even the Wikipedia one, there is the same thing. That means we are making or developing a computer systems which can perform a task now, which was supposed to done by the human or human intelligence, such as some examples they have given: recognizing speech, making a decisions, identify patterns. So AI is basically the umbrella. AI, artificial intelligence, is the umbrella under which few other technologies comes. That is basically machine learning, deep learning, natural language processing, etc. Natural language processing is also part of machine learning or deep learning. Both approaches are there. Few examples. All of us are familiar with, whether we are from technology or not. ChatGPT, any generative AI. We generally translate a text from English to Bengali or some other languages using Google Translate, or Hindi to English, Google Translate. We know that Netflix and RS, which is a very much popular nowadays as far as the movie and movie recommendations are concerned. We're talking about the autonomous vehicles. Tesla is basically the leading. So all those are the examples of AI. Now, what is machine learning? Machine learning, basically, we are trying to develop a system where we're making machine to learn from the data. As human learn from different instances, if we take a newborn baby, the baby is basically getting some information from, initially, the first teacher for any baby is mother. So mother is going to guide the baby what to do, what not to do at the initial pages. So these are basically the supervised learning. I will come later. And after that, whenever it's a grown-up boy, child, or grown-up man, we generally learn from the environment. So here we are making a machine which can learn from the data. That is basically machine learning. Now, whenever we are discussing the machine learning, again, I have tried to identify two most well-known, two most structured and well-accepted definition. One is that Arthur Samuel, who is a pioneer in machine learning. As per the Arthur Samuel, machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. This is one of the finest definition I find. Like, this definition is telling what is the difference between a normal programming and a machine learning program. So machine learning is basically giving computer the ability to learn without being explicitly programmed. So actually, this definition is basically application of AI. So just above I have written application of AI that is involving the algorithm and data that automatically analyze and make decisions by itself without human intervention. So here one term which is very common, that is without human intervention or without being explicitly programmed, computer can learn. Another definition that is to some extent the engineering oriented, that has been given in, this is much later in 1997 by Tom Mitchell. As per him, as per the scientist, the machine learning means he has used some term, like he has used a term called experience, which is being denoted by E. Define a term, that is because we are using computer to do some tasks, so T. And definitely, whenever a computer or a human is doing a task, we generally judge the performance. Based on performance, we generally judge which one is efficient, which one is better. So here, he has used another term called P. And then it says, so a computer program is said to learn from the experience E with respect to some task. So a task has been given to computer is learning from the experience. And at the same time, when computer is doing the task, we are going to measure the performance. So its performance on T and measured by P improve with experience E. So we are, that is the reason who knows, like some of us who are aware about machine learning, we know that whenever we are actually learning a model, we generally use more instances. So that means we are giving more experience so that people can learn. It's not only true for the machine, it's true for the human also. Whenever, so that's why we give importance to the experience. So in the same way, he has nicely defined the term. So one example now. Suppose I want a program to like label my email, whether it is basically a spam or not spam. Okay, I'm extremely sorry. It will be just a type mistake. It will be spam. So whether the mail is spam or not. So that is basically spam filter. Any kind of mail, whenever we are using, starting from Gmail to any mail domain, we will be getting such kind of services. So here also this is an example of machine learning. Normally, it is not expected that we are getting thousands or lakhs of mail. Somebody will manually do that. It's not possible. So there is a computer system which are basically learning and which are actually identifying whether a mail is a spam mail. If it is a spam mail, that is going to spam folder. If it is not a spam mail, that is coming to inbox folder. So I'll try to use this application with the definition that basically Tom Mitchell has given. So here, filtering is basically what is the task? Labeling email as spam or not spam. So this is basically the task. Here we have used the task T. So this is basically the task. The computer system or the computer model or the program will try to understand whether the mail is a spam mail or not spam mail. What is the experience in this case? It is watching the label of email as spam or not spam. So it has learned what kind of mails are being treated as spam, what kind of mails are not being treated as not spam. So this is the experience. What is the performance measure? All of us have seen that we are supposed to get a mail, say suppose from university or from other important sources, and then we have seen mistakenly the mail has been taken to spam folder. So definitely that is an error. So here definitely how accurately over time, how accurately the mail program will identify, will praise, will appreciate. So this is basically the performance measure. It's true for the human being also. So the number or the fraction of email correctly labeled as spam or not spam. Again, a typing mistake, it would be spam, not spam. So this is basically performance measure. And what is the learning? Gradually, the program will be trying to do that task accurately. As many filtering it will do. So that's you have seen. So suppose mistakenly we have received a mail from one of the important sources, and mistakenly my mail program has labeled it as a spam. So maybe we are going to spam folder, and we have seen that one of our very important mail that is being the spam folder, because the program which are actually labeling that, the program is not aware, and based on certain criteria, it has taken it mistakenly to spam. Once you make it as a not spam, so that was basically the learning for the program. Next time you will not get that kind of mail to come to the spam folder. So once you authorize one mail domain or one mail ID as a not spam, you will see from the next time the mail will come to your inbox folder. So this is basically the learning for the program. Now, what are the fundamental differences between basically programming and machine learning? This is one of the foundation concept, and often when we go to take class to our students for machine learning, such questions, I'm sure how many of us who have taken machine learning foundation classes, almost all of us has faced such kind of questions. So what is the difference between a traditional program and machine learning? Because in traditional program, you are using C or Python. In machine learning also, you are using Python. So languages are remain same. So what is the difference between a machine learning program and a traditional program? I've tried to explain it with a diagram, so the right side. In the case of traditional program, what exactly we do, we provide the data and we provide the program to the computer. So suppose I'd like to calculate whether the number is factorial or not. So, or a number is prime or not. It's a very basic program that we give any of the programming classes. So there what I'll do, I'll give some data, I'll give some program. The program would have the logic, how to treat a number is prime or non-prime, and then my program will give the output. So this is basically the traditional program. What happened in the case of machine learning? In the case of machine learning, we are giving huge data, and we are telling that based on this data, what would be the output. Now the computer will train the model to learn how to get the output from the data. Definitely, the first instance, the output may not be correct. So there may be some error. We generally try to fine tune the model. We actually again train, retrain, and then we'll get the correct model. One example. If we are, I'm sure all of us, we are aware about the weather forecasting, and majorly nowadays weather forecasting are accurate. So how this weather forecasting takes place? All those weather offices, they are having the data for suppose past 100 years. So what are the parameters they are storing? What are the features? So suppose they are storing the humidity, suppose they are storing the temperature, and they are storing wind speed and few other parameters. And then what was the result, whether it was a raining or it was a rainy day or sunny day, suppose this is, or cloudy days, this is a level. So these data are already labeled. Now, such huge kind like data for the past 100 years, we are actually training the model, our model, to learn if these are the feature values, then the day should be rainy, or day should be cloudy, or day should be sunny. So based on a huge amount of data, now the program understand that on what are the features, based on what are the values, it will be which kind of day among those three. Now, if you give today's input there, your program can predict. So the example here I have given, this is basically one type of machine learning that we refer as supervised. There are a few other types also, but this is how machine learning works. So the difference between a normal computer software and a machine learning is that a human developer has not given code. That means definitely few programs are required. So it's not that the machine learning we do not write down the program, but there we write down the program or the codes so that my model can understand, my model can learn from the data and output. This is a fundamental difference between a traditional program and machine learning. Now, as I have mentioned a few minutes back, that is basically the supervised learning. So there are various types of machine learning algorithm, primarily based on whether they are trained or with some supervision, or they are learning by themselves. Based on that, the categories are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Very quickly, I'll try to give some input into those cases so that we can just briefly understand what are the fundamental differences. I'll just try to show it through the application. Due to shortage of time, I cannot go into much more details, but I'll just try to give a brief concept. This is an example of supervised learning. So if we see this diagram here, it clearly says on the left-hand side what it is telling. So we are having our training data that I have just mentioned. Say in the case of weather forecasting, we can say we are having the huge past 100 years of data. We are having a learning algorithm which are actually learning. Now we are giving X value, it is going to predict Y. So here we are having few observations X. What can be the best level for Y? This is the question. Now how it can level Y? It can level based on previously the model has been trained with the desired solution. Like the example I have given for the weather forecasting, here the previous 100 years data are basically the input based on which the model has been trained. So this is, so here we understand in the case of supervised learning, we have something called teacher who are basically going to train it. Somebody is going to supervise during the learning process. In the case of unsupervised learning, so in the case of supervised learning, we have seen one term is basically the label. So the trained data are labeled, right? Banking institutions, they are actually using whether the transaction can be a fraudulent one or not. This is also supervised learning example. In the case of unsupervised learning, so one example, if I talk about supervised learning, classification, regression, those are basically the supervised learning model. Unsupervised learning means where the training data are unlabeled. So suppose 100 of attendees who are attending this FDP, we'd like to group them into 3-4 categories. Maybe the grouping may be based on the domain. Grouping may be based on the domain and their qualification. Grouping may be based on their domain and what are the subjects they teach. So here initially the data are unlabeled. We are basically trying to group it. One example is basically clustering. So here generally we do not have someone who will be supervising or will be telling beforehand based on what I need to do that. So that's why it is referred as an unsupervised. Semi-supervised means it's a combination of previous two. Some of the data are labeled where we are using the supervised approach, some of the label data are unlabeled. So this is basically the semi-supervised model. And last one, this is reinforcement learning. So reinforcement learning, one example I can mention here. Say how all of us we have learned that basically riding bicycles or riding a bike. Initially, what we have done, or how does a baby or a child learn how to walk? This is an example of reinforcement learning. So if I take example of baby, the baby is trying to walk. Sometimes if it is not proper, he or she is falling down. So that is basically one penalty or punishment. So definitely when the baby is basically giving up steps proper, the baby can move forward. Same as in the case of bicycle riding. If your bicycle riding is not proper, you are falling down. So that is basically a penalty that is being given. We generally use the term penalty. And then once you are having a penalty, you understand that, okay, this is the wrong step or this is the wrong thing I'm doing. So I'm trying to do it correct. So here, it is actually learning by observing the environment and based on your actions. You can get rewards if you are successful. So that means you can understand, fine, this is the process I should do. Or you can get penalties, which is basically known as the negative rewards, from where you understand those are the steps, you must not do this. So the diagram on the right side, how can you like make a robot learn whether to go to the fire or to use the water? So this is basically one example that we have given. Now, if we go through the timeline, this is where the AI has started in 1950s, and then in 1980s, machine learning, and then in 2010. So what are the broad difference between these three, primarily? AI, machine learning, and deep learning. So broadly, look, deep learning or initially machine learning comes under AI. Machine learning, look, artificial intelligence means we want a machine to behave like a human. So if we want a machine to behave like a human, then you have to make the machine learn. So the learning part is being done by machine learning. So AI, if you'd like to broadly say, I've just clearly mentioned here through some keywords. So AI are basically some of the algorithms or programs that mimic the intelligence of the human. So that means we want a machine to behave or to solve problems like an intelligent human being. Now, what is machine learning? Now, machine learning means here you are trying to machine to learn so that it can act intelligently in AI. Here, whenever you are representing a data, we represent it based on certain attribute or features. So suppose for me, if I'm considering me as a teacher at NSHM, my attributes may be my name, my employee ID, my domain, my designation, my expertise. Those are the different kind of features. So that we refer as an attribute or features. So for any, so suppose if somebody would like to know whether I can take a subjects or not, at that point of time, what is my background, from where I am coming, or what is my height, that is not important. Whether I can teach a subject or not, that depends on whether I have expertise on that. So definitely, whenever you are having one teacher, you'll be getting multiple attributes, multiple features. Not all the features are required for all kind of machine learning problem. So in the case of machine learning, normally the feature selection are being done by manually, by the human. Or we can use some of the algorithms also, some of the techniques which are basically being used, like BCET, principal component analysis, is one of the examples which are being used. But other than that, in the case of deep learning, this feature selection is being done majorly by the program itself. So what are the features, are the important features? That selection will be done by the the program itself. This is basically the fundamental difference of the machine learning and deep learning. Another difference, whenever we generally explain, we say that in the case of deep learning, we are having multiple layers. So in that sense, we are having a deep learning and shallow learning. So, but the primary difference between a machine learning and deep learning is, I think the smart answer would be that in the case of machine learning, the feature selection is being done basically by the human. So machine learning mostly uses the human extracted features to improve the performance. Whether in the case of deep learning, the feature selection is being done by the model itself, and then this is how it is going to improve. Some of the common applications of machine learning or deep learning: face recognition, augmented reality, chatbot, healthcare. Today we'll be talking about the healthcare. Spam detection I have initially discussed, and definitely the driver surveillance, whether the driver is sleeping or not. So there are many models which are coming to reduce the accident, whether the driver is feeling sleepy or not. Accordingly, the speed will be controlled or warning will be generated. So this is also again another use of AI ML, and particularly is going for the complex model. So majorly we are going for the deep learning. Now the question is, why AI and ML is essential in healthcare? So if we see the healthcare, particularly for global aspect or for our country, there's a huge challenge it is facing. Firstly, the complexity in diseases. As much as we explore the technology, we explore more like basically facts. Earlier, say 100 years back, when a person died from a disease, many of the cases it has not been diagnosed. But with the help of technology, here we are having the facility to diagnose. And definitely in that case, and definitely the population is also huge. Sometimes people says that the number of diseases are also has been increased. There's a debate whether disease has been increased or not, because earlier maybe people died and disease was not identified. So if you consider that basically the average span of life, a human being, that has been increased, particularly for our country or for global respect also, for most of the countries that has been increased. So I do not think that the number of diseases has been increased extensively. Yes, few diseases that has been spread widely, that is true. But then there were many diseases which were not identified earlier, which has been identified, doctors are trying to cure. So here, everybody is trying to get, or I think that is their right to get the proper treatment. So here the patient demands are basically high. Earlier, the population was less. A major number of population for our country or for the world was outside of the healthcare domain. But then now, like government and the society, this is basically trying to give that, bring all the human, all the citizen to bring. Even why only human? Animals are also, we are trying to like provide treatments. So here for the healthcare, if you are primarily considering for the human being, our treatment, our diagnosis will be, the chances of cure will be more. The cost of the healthcare are increasing. This is also one debatable issue in social science, and definitely the limitation of resources. If we take the growth in population, primarily the developing countries, and a population growth, the way population is growing, not in the same way the country can create resources. So definitely there's a resource constraint, resource limitation, because resources are always limited. So if we consider these are the challenges, then definitely AI ML, we have we can see what are the different advantages, why we will be using AI ML for that. First of all, we know that machines are much more faster than human. So definitely in diagnosis or in analyzing the data, AI or ML can diagnose in a large scale. Scalability is there. If we consider that one diagnosis a human is doing the same accuracy as machine, although it's not true, still if we consider with the sake of the debate, still the speed of a machine that outperforms the human speed. So speed in diagnosis and analysis is one of the reasons. Secondly, the accuracy. If you are asking a person to work for a longer period of time or even shorter period of time in few cases, the chances of accuracy in the case of human is comparatively less compared to the machine. I'm sure all of us will agree with that. And definitely to export the data, whenever we are giving the complex data, there's a chance that the human accuracy decreases, but the machine is going to perform with the same energy, same efficiency. Thirdly, the scalability, just now I have mentioned. So vast patient data, the scalability, that basically one of the major issues. Because if you want to bring all the people on earth under the medical coverage of the healthcare support, then definitely we must have the scalability support. And scalability can be achieved only by machine, only by computer. So here AI ML are actually providing the unique advantages, are trying to address those issues. Now, this is what we have understand, like why, what is AI, what is ML, what are the different types of ML, and definitely why AI ML is essential in healthcare. Now, next, we are going for the recommendation system. Recommendation system is not an isolated field. It's basically using some of the social science theory along with the machine learning. So we are using human behavior, behavioral theory, some of the social science theories, and basically the computer science theory. So we'll try to understand what is the recommendation system, and we're having some confusion between recommendation system and searching. So we'll try to see later on that what are the differences between these two. Formal definition, if you're looking for what is a recommendation system, or sometimes it is being referred as a recommender system as well. So recommender system or recommendation systems are the same thing. So recommendation system is basically the system that suggests product, content, or information based on the user data. So whatever we are looking for the agentic AI, that is basically one extensive use of recommendation system. When an agent is doing something for you, that means also it is going to suggest which news to follow. I think many of our smartphones is having that kind of applications which are selecting the news for us. From the many news headlines, it is selecting those news where maybe I may have interest or useful for me. So this is again one example of recommendation system. So what is the goal of recommendation? The goal of recommendation is to come up with a short list of items that fits the user interest. So we can go to Google, we can search, but then we will be getting the huge list. Maybe the best top 10 list may not be as per my requirement. So here what recommendation system will do, recommendation system will provide a short list of items which is going to fit with my interest, my requirement. So personalization, whenever we are going for like nowadays, like AI is doing the mass customization and mass personalization. So personalization means the AI providing solution for you and AI providing solution for me on the same problem are different based on our context. So if we'd like to do personalization, we need to use recommendation system, because normally searching cannot do. Example, Netflix, Amazon, those are basically, so the product being recommended to you by Amazon is different then the product will be recommended to me. Maybe both of us, we brought the same smartphone, but next time when they are recommending, maybe some of the recommendations are same, some of the recommendations are different. So here basically we are going for the personalized. So person specific, that will vary. Now, what is the main idea behind recommendation system? So normally a recommender system is going to use the historic data. So whatever transactions, whatever likings you have, whatever in the case of healthcare, whatever diseases you have, what are the lifestyle you are going to follow, all those previous data are required. So definitely that may be a challenge also whenever you are applying recommendation system for like first time to any of the user. For example, whenever you are the first time visitor to Amazon, definitely Amazon faces some problem to suggest, although they suggest, but then the algorithm is basically facing some challenge that we refer as a cold start problem. That is one of the limitations or one of the challenges of recommender system. We're not discussing it right now, but if you are interested in recommender system, one of the upcoming area, one of the very innovative field, then you can go through what are the challenges the recommendation system are going to face. Cold start problem is one of the problems which are basically first time when you are going to recommend where the data are not available. So Here, recommender system is using the historical data of the users or the services that user is using. So here we can, if you'd like to formulate, so recommender system can be mentioned like it has a set of users and definitely a set of items. The items may be a physical goods, it may be a service. So the item may be whenever you are buying a smartphone or your car, or you are taking a service. Service may be healthcare service may be e-learning service may be you are actually taking the help of some of the AI agent for planning your tour plan or your travel plan. So all those are coming the services. So that we actually consider at I. So here it is going to recommend based on, it takes a set of user U and a set of items I and learn a function F such that it can recommend the best item to the user. So this is basically the basic idea behind the recommender system. So definitely whatever I have discussed so far, who are very new in this field, they may be confused with recommendation and search. Yes, when I have taken this field as my research area, at that point of time also I was confused and I have asked my teacher, what is the fundamental difference between recommendation system and search? And the answer I got, that is I have tried to mention here. Actually, we can get answer from search also. If you're using any search engine, we can get. But then searching is primarily, if it is not customized search, in a general search, searching is being done based on your query. So it's basically trying to give the best possible answers against the query. Now, who is issuing the query? That is not being considered in a normal search. So for example, if a person is searching for a text, say best 2024 movie to watch using Google. So if the query is being generated by an old person, normally the result will get, if a query is being given by an adult or even one child of 8 years, will be getting the same result. So in the case of search, generally it will provide the same result and it will try to give the best output for your queries that you have generated. It will not consider who has initiated the query. So that means the context will not be considered. The profile of the person or the user will not be considered. So here we can say search engine results are not customized. So recommendation systems are primarily two types. We can mix these two and we can make three. One is the content-based method. From the name it suggests that in the case of content-based method, it is trying to find out the similarity between the user and the existing item. So suppose you are having a list of items which are having certain features, and it is trying to understand your profile, maybe your demographic profile, your age, your choices, and then it is trying to match your profile with the product profile. Product may be, as I have mentioned, it may be tangible, it may be services also, okay, intangible. So it may be goods, physical goods, it may be products. So it is trying to match the person or the user here in this case along with the item. This is basically the base of the content-based method. And here we are going for the similarity. Okay, Pearson's, we are coming into that. Second approach is basically the collaborating filtering. What is being done here in this case, it is being observed that your preferences, your choices, and it is trying to match with similar user choices. And then the similar user, whatever items may prefer, those items may be suggested to you. So collaborative filtering is basically considering a wider approach which is logical. So if I know X is like A or B or C, and if I know the choice of A, B, C, I can suggest something to X. So how can I tell X is similar to A? I can take the preferences or the likings of A. If possible, I can take the preferences or likings of A, B, and C for the same item or similar kind of services. And then if we see those are almost similar, then I can tell then the preferences or likings of X are similar to ABC. So if ABC are going to prefer, then we can provide that. Now, definitely one contradiction comes here. Only preferences are okay. Maybe we need to consider some of the background story. So here the hybrid approaches comes, which combines the content-based approach and collaborative approach together. So as I have mentioned, this is basically the content-based recommendation algorithms. So this is the user profile. This is basically the item. And then we can recommend the topmost similar items to the user. So here we are using basically the cosine similarity among the user and among the items by using the features. Collaborative filtering are of two types. One is memory-based, another is model-based. So memory-based collaborative filtering is basically, here the term memory means you must have past data, so where the previous ratings are being associated. So that means if you go to Amazon or if you go to any of Netflix, the movie you have seen, you have rated, next time when a movie will be recommended to you, it will go through your previous ratings. So I'll show how these ratings are being stored in the form of a matrix. And in the case of model-based, as the term suggests, there is a model, which is basically a hypothesis. And the model is going to govern how user rate items. So we can use some sort of approximation, like some techniques are basically being used here to recommend, and then also after that we are going to use the or it is going to recommend the ratings. So in the case of memory-based collaborative filtering, we get two approaches. One is basically the user-based collaborative filtering, and another is item-based collaborative filtering. So if we see the right side diagram, it will tell. So suppose U3 and U4, they're basically we see that the choices of U3 for item 1 is choice 2, U4 is 5. U3, I2 choice is 5, it is 2. For I3, U2 choice is 2, but U4 is liking at 3. So here we see U3 and U4, they are not having similarity. But suppose, for the sake of the discussion, if the rating of U3 is similar to U4, now for a new item I5, U5 likes it, we can say that U3 also may like it. So this is basically the user base. So here, what is the philosophy? We're trying to find out a user for whom we are going to recommend. We're trying to find out the similar users to that user. Now, once I get the similar user, if I see that similar users are liking those, not one user, if I try to find out a set of the top similar users, and if we see the top set of similar users are liking that product, then we will be recommending the product to that user, to the new user. In the case of item-based, we are actually doing it similarity among the items. So as in the case of user-based, we have done similarity among the users. In the case of items, we have seen the similarity among the items. So we have seen what are the items similar to one item based on their likings. And if we see that one item is being liked, then definitely I can suggest similar items also. So item that has received similar ratings previously from users are likely to receive the similar rating from further users also, or future users also. Among these two approaches, generally, item-based approaches are basically much more popular. Why? Because user-based approaches where you need similar users, with large number of users, and if it's a smallest change in the user data, it will actually change. So whenever the applications that we see in the case of Amazon or similar kind of products, they mostly depends on item-based filtering, not basically user-based filtering. Okay. So how do we find out the similarity? We are using the cosine similarity. and we are tracking basically whether user U and user V, whether they are similar or not based on their rating. We are using basically Pearson's correlation coefficient for that. I'll show an example. So here, suppose this is a product. Just see here, user-based collaborative filtering. There are 4 movies: Lion King, Aladdin, Mulan, and Anastasia. So among those 4 movies, we are trying to understand whether the Jane will like Aladdin movie or not. What may be the rating for Aladdin movie for Jane. So what I'll try to do, I'll try to understand among those 5 users, who is similar to Jane, whose rating is similar to Jane. If we see that Jane is similar to Joe, then we can tell if Joan likes this movie, Jane also may like it. I think I could make it to some extent clear. I've taken a very small example. I've taken 5 users and 4 movies. I would like to understand whether the Aladdin movie to be suggested to Jane or not. So my recommendation model would like to understand whether the Aladdin movie may be suggested to Jane or not. So what I'll try to do in the case of user based, I'll try to find out the similar user to Jane. So that means whose ratings are similar to Jane. Ratings for similar to Jane means rating for other movies where Jane has given a rating, what rating those users has given, and whose ratings are very similar to Jane will be using. So here we have used basically the formula, correlation coefficient formula, and then we found here through the calculation that Jane and Joan, their similarity is 0.73, Jane and Joe similarity is 0.88, Jane and Jill similarity is 0.48, Jane and George similarity is 0.84. So among those 4 similarity, we see that Jane and Joe's are much more similar, 0.88. So let us see the rating of Joan for that product. Rating of Joan for Aladdin was basically 4. So we can suggest Aladdin movie to Jane also. So this is how the user-based collaborative filtering works. Right? So this is how. Now definitely next question is, what may be the rating of Jane? If you see here, look, Joe is very open-minded. In a scale of 5, Joe has given 5. But maybe Jane is to some extent conservative. His higher rating is 3 because he has given 0 in some of the cases. Although we see that Joe has also given 0, but Joe has given some high value also. So what value Jane can give? So that means that trend you can see what is the Jane's rating style or rating trends. So this is how we calculate that rate. What rating Jane will give for Aladdin is basically the average rating of Jane, that is 1.33. If we divide 3 plus 4 plus 0, because 3 ratings are there, so 4 divided by 3, so we are giving 1.3. So 1.33 is the average rating. We are getting similarity of Jane and Joe. What was the rating given by Joe to Aladdin? What is the average rating of Joe? Divided by similarity of Jane and Joe plus similarity of Jane and George. Right? So we have just used here this formula to use. Why we have used 2? Because we are here, we are using as I told you, that whenever we are finding similarity for the accuracy of computation or to beat statistical significance, we do not compare it with the one person's likings. I try to take the top 2 or 3. Like in this case, we have taken top 2. One is basically, if we take top 2 figure from here, Jane is similar to Joe, and then second highest, Jane is similar to George. So we are using basically Jane and George's rating. Okay. So that is what we have done. And then by using these values, we can get the rating 2.33. So we can say that Jane can give approximately a value 2.333. Now 2.33 is close to 2.5. If you see the Jane's rating, 2.5 above or 2.5 close to is the higher rating for Jane. So Jane may like the Aladdin movie. this is the technique which are being followed by Amazon or any kind of such who are basically providing the suggestions to us. Even whenever Facebook suggests or LinkedIn suggests some profiles, they also do the similar kind of calculations. Now we'll see what is the use of healthcare. So item based, as we have seen, is basically from the user similarity. In the case of item, we actually try to use the similarity among the items. Okay, due to lack of time, I'm not going it. If required, I can share the material, and the same concept are being used. The same thing, we're trying to find out the similar between items. Now, so as far as like our topics are concerned, we have discussed what is machine learning, the foundation. What is the foundation of recommendation systems? Now, what is sustainability and what do we mean by the sustainable healthcare? So sustainability are basically, whenever we discuss about sustainability, we often discuss about the United Nations Sustainable Goals. United Nations Sustainable Goals there are total 17 goals United Nations has defined, and they're trying to meet by that 2030. So they have defined those goals in 2015 to make the earth as a better place to live. So here we'll be getting the goal number 1, no poverty, goal number 2, zero hunger, goal number 3, if we go, that is basically good health and well-being. So this is directly linked with the sustainable healthcare. So the aim should be to provide good health of all the people on earth and to move forward with or to take necessary measures for the well-being of the human being. Okay, so although there are some indirect SDGs are also linked, because good health, if you want, you need the basically clean water. So that options are also there. So 6 is to some extent linked with this. Gender equity is also linked with that. If you are having proper education, linked, but direct one, if people are hunger, if you cannot remove hunger, like hungerness, then definitely you cannot think much about the nutrition. So if there's some malnutrition, if there's a poverty, then you cannot expect the good health. So all those are other SDGs are also related, but SDG 3 is directly with basically the sustainable healthcare. Now, what do we mean by the sustainability? Sustainability development means, if we are taking the definition what United Nations has given in 1987 in one of their commissions, that says you are trying to meet the need of the present without compromising the ability of future generations to meet their own needs. Say we are talking about the renewable energy from say suppose basically from renewable resources. Okay, so like the power from solar cell, power from winds, those we are considering as basically sustainable energy source. Why? Because we are not using petroleum, which are having a limited resources or which are basically limited, which not basically unlimited resources. So we are not using those kind of resources. We are using some of the resources which are basically helping us to be sustainable. So why solar energy is sustainable? Now, if we produce electricity from solar energy, then we are not going to compromise the future generation need, because solar energy, like at that point of time, also future generation, when they will come, they also can generate. But if we are using petroleum right now, if we are using ground level water right now, and if we do not have provision to have petroleum to have ground level water increased, then definitely future generation will not get it. And already in few places that has been started, and some of the wars among the countries are also maybe because of those kind of products, petroleum, concentrated water like that. So that we see into newspaper. So sustainability means you are developing, you are sustaining without compromising with the need of the future. Now, what is sustainable healthcare? Sustainable healthcare means you are trying to deliver the high quality healthcare with optimized use of resources, and you are going to ensure the long-term viability. That means again the same thing. You are providing the best healthcare services, but at the same time you are considering the sustainability in mind. So as far as when you are using the resources and other tools, you must not use such resources which are limited so that the future generation may suffer. So sustainable healthcare goals may be you are going to reduce the waste or resources and optimize healthcare delivery and enhance the equity of personalizing patient care. At the same time, you are giving the individual need. You are not treating similar all patient as a similar. You are trying to give a personalized patient care. Now, how machine learning can be used in this case? Machine learning can be used for the predictive analysis. So that means I can predict what are the resources are required for the operating for the hospital operations, healthcare operations. What are the tests are actually required, not going for the unnecessary test, because whenever you are going for the test, it is using some chemicals, it is using some electricity. So again, sustainability is in question. And you are basically going for the accurate forecasting of the patient need. So this is the one applications of predictive analytics. Resource optimization, you are trying to use the best or optimize use of the resources. And that is possible only when you are having the information. So data-driven analysis is most required in this case, so where machine learning is involved. And definitely you are trying to make it the healthcare services affordable. So that means the cost reduction. How can we achieve this? Recommendation system is widely, as I have mentioned, is being used for the personalized care. So one example is that you can have a personalized treatment plan. You are not providing the same treatment from where the precision healthcare is in place. So that means generally whenever we are suffering from one disease, we are taking medicine. So medicine is working on each and every cells. Instead of doing that, the scientists, the biologists, they are thinking to go to that particular cell and then to cure the disease. Many researchers particularly in the field of cancer is going on. So these are basically we refer as a precision healthcare. So precision healthcare is basically one extension of the personalized treatment. You can have a preventive recommendations. So that means you can go different kind of mapping. You can have some early diagnosis, and you can actually predict whether the possibilities of the disease or not. One of the most common example is that the PSA is one test that is being done for the male for the prostate to basically predict whether in future prostate can have something or not. For the cancer patient, gene mapping can be also done to understand what is the likelihood that there's a chance that can be there. So these are preventive recommendations that can be done. And patient engagement that all of us we are familiar with. If you are looking for any of the multi-specialty or super specialty hospitals, they are having different kind of apps which are going to follow up. You are telling that you are having this text. Even if you get medicine from some of the shops, they are also going to warn you before your medicine exhausts. They are going to tell you the lifestyle changes, and definitely what are the medication, different kind of agents are there who are actually guiding you that what are the doses, whether you have taken the doses or not. So these are the areas where recommendation system can be used, and all those developed countries, they have started to use widely the recommendation system for the healthcare. Okay. So with the help of the predictive analysis, we can use that managing hospital resources like availability, staffing, and inventory. AI-driven system that predict peak patient inflow when the patient flow will be more. At that time, maybe they may call more number of staffs. When the patient flow is likely to be less, you can work with the less staff, because less staff is not only you are require less human resources. Whenever your office is basically full with more number of staffs, some sort of electricity for their need are also required. So you can reduce those also. Okay. So, and whenever you are having more patient flow at that point of time, if you are calling more staffs, then definitely you can reduce the patient wait time and your service can be better. Telemedicine is a very well-known area where machine learning plays a major role. Telemedicine, we know that if we like to provide the standard healthcare services to the rural areas, then through the remote access, we can provide. And a country like us in India, we do not have that much adequate doctors or the healthcare facilities. So telemedicine is very popular. Even why only in rural in India? So suppose you are moving from one city to another city, you have some follow-up. So instead of going personally there, you can take help of telemedicine to follow up with the doctors. And machine learning is widely used for the telemedicine as far as is the diagnosis are concerned, monitoring are concerned, or even the patient interactions are concerned. Or as few minutes back I mentioned, all those big hospital chains, so Narayana, Apollo, they are having very AI-enabled chatbots which are actually guiding you for your appointment, for your medicine, for your tests. And even some of the cases, it is going for the initial patient screening also. And it is going to suggest you what recommendations can be done. Recent Smart India Hackathon for the past 2 years, they actually government is also giving more focus in these areas. And I do remember there are many problem statements in these areas. That is the patient screening, initial patient screening and recommendation. So this is one of the areas where research can be taken forward. Mental health is one of the major issues that actually we all have realized after the COVID period possibly. And for the healthcare, for the good health, as physical fitness is required, at the same time your mental health also is very much important. And mental health here, recommendation systems and machine learning can play a major role. Government UGC are basically coming up. There are few already developed. They're coming up different kind of chatbot applications for the mental health of the students, where they're asking for some data. Students can install that chatbot into their smartphones. They can interact with them. That can help in terms of therapy. It can give some further recommendations also based on the mental. We have seen that some of the applications research that the recommendation system will suggest you the songs as a part of the therapy based on your mental conditions. So this can be done. Some of our researches we have done, as I told you, that we are trying to understand the anxiety and stress level or depression level from social media posts, so through sentiment analysis. So such things, initiatives also can be done. I'll discuss it at the end, where we'll be going through. So these are the applications of recommendation system in mental health support that just now we have discussed. So if we talk about AI ML in the healthcare broadly, these are the following areas where AI and ML can be used. You cannot get a single areas associated with healthcare services where AI ML or recommendation systems cannot be used. Each and every aspect, starting from the health record management to mental health, to radiology and medical imaging, to telemedicine, everywhere AI MLs are widely used. Some of the case studies, like I'll try to show, like this is a disease detection and prediction. If we go through, we'll be going through that. In majority of the cases, like if we go for say MRI or CT scans, majorly new machines are always coming up with the AI ML support. So it is basically some of the ICUs are also coming up with AI ML and recommendation support. So each time they're capturing signals through different kind of sensors, and the data is being passed to the doctor for a better decision, and 24/7 sense. So this is from detecting disease and prediction, where AI ML can play a major role, from continuous monitoring to occasional test. Drug discovery, the research on drugs are being done with the help of AI ML, because earlier to develop a drug, because it was taking too much time. One example is basically the vaccination or the vaccine of COVID. It was produced so fast only because of AI and ML. So AI and ML is having a huge applications in drug discovery and development. AI powered computational pathology, here also all the big labs, they generally say that they are basically AI powered lab. So yes, AI and ML is having a wide applications in pathology, also in computational pathology, and the subject also came it like that AI in computational pathology. So those are the different, so not only AI is a combination of basically, obviously clinical expertise is required. At the same time, it can be combined with some computational knowledge, and definitely for the statistics to have an AI-powered pathology. AI ML in radiology, just a few minutes back I have mentioned. So this is how, this is a complete picture I have taken from one of the US hospitals, like their brochure, where they are telling that how a patient is being monitored from a remote distance. Continuously the patient health are being monitored with the help of AI ML and recommendation systems, where definitely AI ML recommendation system is there and sensor plays a major role. The data processing clouds are also required. So all those are interlinked, but this is how can be done. That means if you are under observation, you do not need to sit in front of the doctor. You do not need to be admitted in the hospital bed. You may have your daily lives, but then you may be monitored. You may be suggested through your chatbot or one AI agent what you need to do, and the doctor can monitor your health. So this is the same thing. So depression detection using NLP is another areas where you can use machine learning and recommendation system because many of the cases, one of the problem of depression for our country like us is particularly not only in rural, even in urban areas, we have seen that people are not concerned about the mental health. So, and if they are concerned, people cannot express their suffering from depression. Firstly, people ignore mental illness as an illness. If somebody recognizes, then to get the proper support is also one issue. Research says that if early detection of any mental health disease or even any kind of disease can actually cure, and that can stop from being damaged. So NLP can play a major role, and that is the reason government of India and few other governments also, they are trying to have those chatbot kind of support for mental health for the youth, primarily who are basically the sufferer from the mental health. Okay. So this is basically the projected model, which how mental health support can be provided through AI and recommendation systems. So you can see those different steps. Like the first of all, you do not need to go to psychologists. So psychologists, so that is reduced cost, they're not costly. You can provide 24 years support. We have seen that you can have the smart, different kind of smart wearable also, through which you can measure different kind of biosignals, and based on that you can suggest. So based on that you can recommend. So this is also again another example of AI ML and recommendation system in healthcare. Telemedicine and remote monitoring already you have discussed. Drug discovery already you have mentioned. Three more applications that is very recent. That is drone delivery through zipline. So they are basically providing that AI-enabled drone to deliver the medical supplies, vaccine and blood to remote and underserved areas. So this is again another example of AI, ML and recommendation system in basically where the infrastructure is a challenge. There you can improve the healthcare, and in our city in Kolkata, in Newtown areas, in Rajarhat areas, such services has already been started. So that is already in place. IBM Watson for oncology is one of the pioneer in oncology research, who are using AI, ML and NLP to diagnose the cancer, to to predict, to so that it can be restricted. So this is again another area. I just can suggest that you can go to the IBM Watson white papers, from where I have taken these contents. They're widely using, and this is successful in major number of cases. During COVID period, we have seen that use of AI, ML and recommendation system in basically healthcare, particularly UNICEF also, they have developed a model, one application that is a magic box. So this is basically an AI-powered supply chain management to predict and meet the healthcare need, particularly for the developing countries during the epidemics. So again, I suggest you all to go through the UNICEF's magic box. This is a basically GUI interface, which are telling that what kind of support that is required, what are the areas which can basically outpass, or what the targeted areas. they can analyze the data, and then they can basically make the supply chain efficient. Supply chain here means supply chain for the medicine and other first aid equipments to that areas, and those services, if it is can be provided in timely way, then definitely many lives can be saved. So those three applications which I have seen recently and which are widely being used across the globe, one is chip lines, drone delivery, IBM Watson's oncology, and definitely the UNICEF's magic box. Now, the second last portion. Now, whenever we are using AI data, definitely we are sharing everything. So there are certain kind of privacy and security concern. So data privacy and security is one area where it's a major concern. What if my data is being used for some other wrong purposes, or I do not want to disclose my digit outside? What about the biasness of the AI model? So the AI model must be fair. It should not provide different treatment or different recommendations for the rich person and the suppose poor people. So it must be fair as far as the healthcare are concerned. Scalability and adaptability is another, whether we can produce it into the large scale or not. So these three are the major challenges whenever we are discussing any kind of AI solution. One is data privacy and security, whether the data is secure or not, whether the data privacy can be maintained or not. Although there are few solutions also already has been introduced. So blockchain and other technologies are also being used to make the data, to protect the data from unwanted uses. Bias and fairness in ML, this is again a controversial discussion, and there are various models which are being used, and that's why whenever any medical solution is being produced, being developed, it cannot be tested directly. There are different kind of ethical and other committees who are basically going to decide whether it is ethically right or not, whether it is unbiased or not. And whenever we are developing a model, it must have that ability to adapt across the globe, so the diverse healthcare settings, and at the same time whether it can be make scalable or not. So the solutions here, we can say that the privacy focused framework that can be implemented, that is already there, people are working on that. Ethical guidelines needs to be followed, bias detection algorithm also in place, and definitely fair algorithm needs to be designed. And now, as far as our research are concerned, we did some researches in the field of AI in mental health. What exactly we did? We have done three primary work. One is that early detection of depression. Second one is that suicide ideation detection from online social media posts. And third one, as we can have an ECG card, whether we can generate one mental health card in the recent past of the patient. So whenever we go to one heart specialist, we generally take the ECG and then we go there, so that from the chart that doctor can understand what is the condition of the health in recent past. Here also, if same thing can be done. So I'm very happy and proud to say that with one of my a few collaborators and few students, we could produce some significant research in this field. Here the diagram, if we go through what exactly we have done, we have collected the data from X, like the Twitter, and definitely from the Reddit. Then after that, we have done the data preparation. We have extracted the features. We have used different kind of techniques. We have analyzed. We have considered here the personality also, because as I have mentioned, for the mental health is not only a sentiment, it's a personality, because if the person is introvert, then you cannot understand whether the person is depressed or not. So after that, we have classified and then we have tried to predict. We have few publications that I'll show at end. If you are interested in this field, we'll be happy to collaborate in that. Our recent work is basically here we are trying to generate a mental health curve. So the same thing, we are actually trying to take data from your social media presence. We have done that data cleaning and others we have prepared. We have taken that feature extraction, we have stored the data, and then based on that, we have taken the sentiment. And so we have tried to understand what is your base level sentiment. And then based on that, we have done this kind of analysis. All the the work that I've mentioned, that has been published in reputed journals. Now, what are the futures of AI ML in healthcare? Augmented reality are being used. Augmented reality is already in place while you are buying a say suppose a lens or say suppose frame from some of the pioneer in glass like Titan Eye, or if you go through Lenskart, they'll be giving. So you don't need to go to shop. You'll be getting one app to download. It will tell you that which frame suits you the better. So the same augmented reality can be used in the surgery in some of the places that it is being used. Mental health support, basically AI would be used in much more larger scale, because a country like us, a major number of population are outside those computing facility. So if we'd like to use the AI, ML and recommendation system or even sensor based, we need infrastructure. So that needs to be developed, and government and other agencies are working towards that. AI in telemedicine and remote patient monitoring, this is also one of the areas, so that we can have an improved access, affordability and preventive care, and we can provide the sustainability to everybody. Then definitely there are few concerns also, like I have tried to present that what will happen if the prediction is wrong. So there we are actually, as from the machine learning point of view, we generally refer it as basically as confusion matrix. So we get generally two types of error there. We say that the type 1 error and type 2 error. To an example, we can tell, like suppose type 1 error may be that you are getting a positive COVID-19 test result where you do not have positive. So suppose you do not have COVID positive, but the report says you are having, so doctor has given you the medicine. So that also should not be there. Type 2 error says that you are getting a negative result, but then you are having COVID positive. So it depends on disease whether the type 1 error is more dangerous or type 2, but normally type 2 error are commonly more dangerous. So we must try to develop the algorithm so that the type 1 error and type 2 error can be reduced. So definitely whether the healthcare can be replaced by AI or not, this is a controversy. I think based on my studies in that field, like machine cannot be a competitor of human, but we think that we can, if we combine the machine learning AI with the human expertise, then we can have a better healthcare support. So for the future direction, maybe IoT for real-time health monitoring, the example already have mentioned, and that is in place in many cases. We can have the advanced telemedicine with machine learning. We can integrate the AI with the basically genomes, like basically data, so genomic data, like the gene mapping and others. A few researchers are going on into some of the top universities. I know, like being an Indian, we must feel proud that Professor Siddhartha Bhattacharya is one of the person who is doing the research on precision healthcare for the breast cancer. So that means you do not need to go for the chemotherapy, you do not need to take a medicine for your entire body. And the AI-driven robot will go to that particular cell, that is, and then that will try to cure that. That will try to cure it at the gene level also. So this is what it is coming, and we all are hopeful that AI, ML and recommendation system will make human lives better in coming days. So ML and recommendation system plays a crucial role in driving sustainable healthcare by improving quality, reduced cost and enhancing access. Already we have discussed. So message here is that leveraging technology for patient-centered and sustainable healthcare. And here I think that innovation of machine learning and AI can transform healthcare into sustainable, equitable service accessible to all. As far as the research are concerned, like the three areas that we have mentioned, we have majorly worked in mental health. So we had a few publications into that areas, like developing, generating a mental health card for monitoring depression, and that got published in one of the very prestigious journal from IGI Global. A two-level multimodal analysis. So whenever we are taking the data not from taking one source, but we must take from different sources, so that we refer as a multimodal. So multimodal recommendation system are actually becoming popular day by day. And multimodal recommendation system, we also have worked one of our work, the second reference, which has got published in Elsevier, one of the Elsevier journal. So this was basically the proposed model. That is what we have discussed. In addition to that, we are having few other publications for suicide ideation detection and basically feature-based depression. So one of the review papers recently has been published, which is very good. This one, a systematic review of healthcare recommender system, open issues, challenges, and techniques. A recent paper in 2023 December that got published in one of the very reputed journal. So these papers are freely available, may follow. I've taken resources, I've taken the concepts from some of the books, out of which for recommendation system, I consider this book is one of the best, like social media mining, freely available on internet from the Cambridge University. I'll be happy to collaborate or to get few questions if you have. Thank you.
Thank you so much, sir, for sharing your valuable knowledge with us. Am I audible, sir?
Yes, yes. So thank you.
Okay, sir. So now we have some questions from the audience, sir. So first question asked by Anushwa Majumdar. Sir, please explain the scenario where we can use collaborating filtering and where we can use content-based filtering in recommended system.
Okay, very good. Thank you for the question. It is absolutely a very good question. Collaborative filtering and content-based filtering are basically two approaches. That is what I have mentioned. So in the case of content-based filtering, where we are having that existing items, we know, so suppose a person who has newly joined to Amazon. The person has provided all the details, but the person did not do much transaction on Amazon. So I have product features that I can utilize. I have the user's details also, but I do not have any history of purchase of the users or likings. So in this case, we can try to match the product features and the customers or the users features, and then we can use content-based filtering. So here we're trying to find out the content similarity. Here content is the features. Collaborative filtering is mostly used when you are having the past data. If you do not have that much of data, then definitely collaborative filtering, because collaborative filtering in this case, you know that you must get the similar user or similar product. So if it's a new product of its category, or if it's a new user of its category, then definitely collaborative filtering cannot produce initially the good results. You must need the past data. So I think alone collaborative filtering or content-based filtering cannot be the best solution. Majorly, whenever we see the industry applications, we see generally the hybrid approach. And always it is taken the multimodal. Why multimodal? The person may have joined Amazon as a new user, but person may have account in other users also. So if you can take data from there, if you can take data from that person's Facebook or WhatsApp or any other social media or any other purchase pattern, then definitely your recommendation would be better. So this is what I feel. Thank you.
Okay. The next question asked by Apurva Vasisht. How can we connect the recommendation system with machine learning?
Actually, for recommendation system, if you are talking about, it is basically one subset of machine learning, and along with some social science theories are like associated, where we are considering the human behaviors. So look, recommendation system is processing a large value like volume of data. So in that sense, it is using machine learning, because once you are developing a recommendation system model, then it is basically predict something or it can recommend something. The recommendation system itself is a machine learning. What you can do, you can use other kind of approaches to fine tune the recommendation system model. So suppose instead of directly using recommendation system, you can use clustering to profile the user data. So your recommendation will be much more accurate.
Okay, sir. Thank you, sir. There is no question.
Thank you, sir.
Mithu ma'am.
Yes, sir. Thank you, sir, for sharing your valuable knowledge with us. It's a truly some FDP and highly informative. Thank you again, sir.
Thank you, madam. Thank you very much. It was pleasure to be invited and to speak for these two topics. So I'll be very happy if in future we see that any of the attendees are interested and to collaborate with us. Thank
Sir,
you.
so one question. Hello,
Yes,
sir.
sir.
Some
Sir, please.
audience ask about the PPT.
Surely I'll share. So can I
Yeah,
can I mail it to Santanu sir? I'll share it.
Yeah, sir. You please send me. I will collect all the PPT from all the resource person and will forward to all.
Right. Mhm. Thank you. So please let me know. I'll be happy to share it with, and if it can help or if you can motivate any person to come into this area, that will be. That is the meaning of doing such kind of sessions from your end and from my end.
Obviously.
Thank you.
Thank you, sir.
Thank you.
Thank you so much.
Thank you, sir, madam. Thank you.